now that we know how to convert from log to exponential and exponential to log, I'm going to show you how to use that skill in order to find inverse functions. So the first part of these notes ask us to graph the line y equals x, which you can see I have there in pink, the graph of f of x equals log of x, and g of x equals 10 to the x power. So I've already got all three of those things graphed. And as you can see, this line y equals x is a reflection line for those two functions. So you can see that the green, if we folded it along that line y equals x, would land directly on top of the blue. So we know from previous units that if two functions do reflect over the line y equals x, they are indeed inverses. So if we were to look at table of points, we would see that the x and the y values from the green function would be flip-flopped to create the blue function. So you can see the intercepts that I marked. The x-intercept for the log function is 1, 0, and the y-intercept for the exponential function is 0, 1. So it's also important to note that for these two functions, they share the same base. So your inverses will have the same base as one another. So this exponential has a base of 10 as well as this log, because remember our common log has a base of 10. So graphically, we said the functions will reflect over the line y equals x. And then if we were to create our compositions, which we discussed earlier in this year, if we would take the function g of x and plug it into f, and take the function f of x and plug it into g, those two compositions, f of g of x and g of f of x, would both simplify down to just a plain x. Okay, as a review, to find the inverse of a function, we follow 4 steps, and only one of them actually involves doing math. So our first step is to change our function notation f of x to y equals. So sometimes that's actually already done for us. Okay, step 2 is to switch our x's and y's. So we're going to change all the x's to y's and y's to x. Step 3 is where we actually have to do the math. So we're going to have to get y back by itself. We're going to have to isolate the y. And then finally, once our y is isolated, we're going to replace that with f inverse of x. We're just going to rename that function so that we know that that one is the inverse. Okay, so this asks us to algebraically show that these two functions are inverses. So it says we want to find the inverse of f of x equals log of x. So step 1 says I'm going to change f of x to y. Done. Step 2 says we're going to switch the x and the y. So I have x equals log of y. Now, this looks like something we don't know anything about. But as I alluded to a while ago, I said that we're going to be using our conversions in order to find the inverse. So judging by that, let's just try to convert this into exponential form. So if you recall, our base for the common log is a 10. And to turn a log equation into an exponential, you're going to start with the base. So this has a base of 10. You're going to come across the equal sign. So that's going to be your exponent, 10 to the x power, and then swing back around, equals y. And then finally, we would replace it with f inverse of x. So f inverse of x equals 10 to the x power. So we've just shown algebraically that the inverse of log of x is 10 to the x power. It is an exponential. Okay, let's show that the reverse is also true. So here I'm going to change g of x to y. Then I'm going to switch my x and my y. So x equals 10 to the y power. Okay, step 3 says we need to solve for y. We need to get that y by itself. Once again, you might not know what to do. You might not know how to get that y by itself. So let's just, like I said, convert it to logarithmic form and see what happens. So we're once again going to start with our base, which is a 10. So I have log base 10, which we can write, but we don't have to write because it's the common log. We go across the equal sign. So of x equals back over here to the y. So now we've got y by itself. And I can rename this g inverse of x equals log of x. So we've shown algebraically that the inverse of an exponential 10 to the x power is log base 10 of x. So looking at example number 1, f of x equals 4 times the log base 2 of x. So I'm going to go ahead and just, instead of changing this to a y and rewriting the whole thing, I'm just going to switch my x and my y right here. So now I have x equals 4 times log base 2 of y. We're trying to solve for this y. We've got to get it by itself. Okay, before we can change it to exponential form, I've got to get rid of this coefficient of 4. So that's essentially 4 times log base 2 of y. So just like if we were dealing with regular x's without the log, we're going to divide both sides by 4. So I get x over 4 equals log base 2 of y. So now that the log is isolated, we can go ahead and change it into exponential form. So we're going to start right here with the base. So I have a base of 2 across the equal sign. So raised to the x over 4 power equals y. And just like that, we've got our y isolated. So I can rewrite this as f inverse of x equals 2 to the x over 4 power. Try another one. Next one, f of x equals log base 6 of x plus 4. So we can't get inside those parentheses because those are part of the logarithm until we convert it to exponential form. So I'm going to go ahead and change my x and my y. So we have x equals log base 6 of y plus 4. Okay, so this log is completely isolated. There's nothing add, subtract, multiplied, or divided outside of the actual logarithm. So we're going to change this to exponential form. So I have my base of 6. Come across here, I have an x, because remember we changed f of x to y and then y to x. So 6 to the x power equals, back around here, y plus 4. So all of that was inside the log. That all goes on the right side of the equal sign. Now we have one more step to get the y isolated. We're going to subtract the 4. So I get y equals 6 to the x power minus 4. And then, of course, we could change this to f inverse of x equals 6 to the x power minus 4. So as you can see here, I went ahead and graphed both the original function, y equals log base 6 of x plus 4, and my inverse, y equals 6 to the x power minus 4, alongside the equation y equals x. So you can see graphically the red and blue function reflect across the line y equals x, which is shown as the green equation on the graph. So we can see graphically that we did find the correct equation. Example number 3 is going to be a little bit different because that plus 9 is outside of the log. So this right here is the log. Okay, so we're going to have to move that plus 9 before we convert it to exponential form. So I'm going to go ahead and change my y to an x, my x to a y, and we're going to start off by subtracting 9. So I have x minus 9 equals log base 3 of y. So now that my log is isolated, I can go ahead and change it to exponential form. So I've got 3 to the x minus 9 power equals y. And the y is isolated. So we can rewrite this as f inverse of x equals 3 to the x minus 9 power and be done. Okay, number 4, we've got an a, c, and a d value inside of our log. So we're going to have to move them one at a time in order to isolate the log. So we've got to get it by itself before we can do anything. So I'm first going to replace my y over here with an x, my x with a y. First step we're going to need to do in order to isolate is move that plus 5. So I have x minus 5 equals 1/2 log base 2 of y minus 1. Okay, it's still not isolated. I've got to get rid of that 1/2. So in order to get rid of 1/2, we can multiply both sides by 2. We want to be careful to multiply everything on the left by 2, not just the x. So this is going to yield 2x minus 10 equals log base 2 of y minus 1. So now that our log is isolated, we can change it to exponential form. So I've got 2 to the 2x minus 10 power equals y minus 1. And then finally, we can add 1 to both sides, which is going to give me f inverse of x equals 2 to the 2x minus 10 power plus 1. So now let's do a couple of examples where we are starting in exponential form. So therefore, our inverse will be a logarithmic function. So tongue twister if you say it too fast. So here we've got g of x equals 6 to the x over 4 power. First thing I'm going to do, change this y to an x to a y. Our exponent is already isolated, so we're going to change it to log format. So I've got log base 6 of x equals, over here, y over 4. To get rid of that 4, we're going to multiply both sides by 4. So we've got y equals 4 times log base 6 of x. Or if we put it in function notation, we've got f inverse of x equals 4 log base 6 of x. Okay, next one. Whoops. Let's go ahead and change our y to an x, our x to a y. We've got a couple of things that we need to do in order to isolate that exponent. So I see that I have a negative out in front. We can either multiply by a negative and then multiply by a 5, or you can attribute this negative down here to the 5. You can think of this as a negative 5. Because if we've got a negative out front, you can send it either to the numerator or to the denominator. It doesn't matter. So we're going to attribute that to the denominator. So we're going to just multiply both sides by negative 5. So the left has negative 5 times x, which is negative 5x, equals 4 to the y power. So now that we're in exponential form, we've got the exponent isolated. I'm going to go ahead and change it over to logarithmic to find the inverse. So I've got log base 4, and then we want to come across our equals of negative 5x equals y. And with that one step, we have our y isolated. So we could say g inverse of x equals log base 4 of negative 5x. Okay, let's get down here to number 8, one last problem. I'm going to go ahead and change my g of x to a y, my y to an x, and then replace the x with a y. So before we can change it to exponential form, I'm going to have to move 2 things. First one is going to be this 3. So I've got x minus 3 equals 9 to the 2y minus 1. Okay, actually, I guess I just needed to move one thing. Now we're going to change this into logarithmic form. So I've got log base 9 of x minus 3 equals 2y minus 1. So now that we've got it in logarithmic form, I can add this 1 to both sides. So I have log base 9 of x minus 3 plus 1 equals 2y. And then I can divide both sides by 2. And I'm dividing everything on the left by 2. So my inverse would be g inverse of x equals log base 9 of x minus 3 plus 1, out of room, so I'm going to scoot it over, plus 1 divided by 2. Everything there is divided by 2. Okay, if you put a 1/2 out in front, that's fine, as long as you include log base 9 of x minus 3 plus 1 in parentheses. You couldn't just put your 1/2 here in front of your log, because that would not apply to the plus 1. And we brought the plus 1 over before we divided by 2, before we found 1/2.